Hello, welcome to the session Data Structure Sorting Gate Questions. At the end of this session, the student will be able to solve a data structure sorting problems. First, we will see Gate Question 2019. An array of 25 distinct elements is to be sorted using QuickSort. Assume that the pivot element is chosen uniformly at random. The probability that the pivot element gets placed in the worst possible location in the first round of partition, what will be the answer? Here I will answer 0.08 because here worst case pivot will be either at first location or last location. So the two possibilities will be 2 by 25 will be 0.08. So what is this pivot? What is the first location? What is the worst location? We will see in the next section. So the quick sort. In the quick sort, we are having three divisions. One is first we are dividing, then we are using the recursive sort and then conquer. So in the divide, what we are doing in the array A, it should be having element 2 or more elements. In that you have to select element X such that it will be work as a pivot. So the pivot, whatever any element you can select as a pivot. So it may be starting element at the last or middle element, any element you will be doing that. Now after selecting the pivot, there will be three subsection will be created. How? First is L, who is less than, whatever the numbers are less than pivot, they will be at the left side. Then equal means whatever the number pivot is there, which number is equal to the pivot, they will be in the E section. And in the G section, that is the greater number than the pivot, will be at the greater section of that. So it will be right side of the array, L section will be at the left side of the array and E section will be preserved, and afterward we will be recursively sort this, and then we will be finally will put all the element in the array A, which first will be L section, then E section which are equal, and then G section which is the greater than our pivot. Now here you will be getting more idea about that. That is the, in this you are having the quick sort, all the elements are there, array elements are there, here array is S, and here any pivot, you will pick any pivot, here 65 is there. Now 65, who is greater than 65 will be in this section right side, and who is smaller than 65, they will be at the left side. And then it is sorted left side, right side, and then it will be merging. So here one example, here we are getting here 85, 24, 63, 45, 17, 31, 96 and 50. Here what we are doing, the last number we will be work as a pivot. So here 50. We will take pivot as a 50. So whatever the greater number than 50 will be at the right side and smaller number at the left side. You can see here. So this is the L section, E, and this is the G section. So again what we are doing, I am showing on the left side only. So left side section, again it is selecting pivot. So 31 will be pivot, whatever the greater than 31 will be at the G section right side, and smaller than 31 it will be at the left side. So here you can see 24 and 17 are coming to the left side. So here we will see that again into the 17 and 24, 17 can be pivot and 24 can be kept on the right side or G section, and smaller than 17, there is no number is available, so we are not putting any number. So we will be returning back as 17 as the number. So then we will returning this 24, then this 17 and 24 will be returned back here by comparison. So here you can see here 17 and 24, 31 and 45 already sorted one. Now like this, these will be compared and then it will be returned to the upper layer. Now this side we have not done anything still. So the same way how we are done in the left side, again it is sent right side. So 85, 63, 96 will be sent to this. If 63 is pivot, then 85 and 96 will be going to the other side of the array. So automatically it will be happening this in this way. So totally you can see here we are getting sorted array. So if we see that how the analyzing of this running time, just we have seen in the first question that how worst case will be there. So the pivot, we are selecting the pivot. So in that way, if we are selecting such a pivot, if it is not balanced properly, means left side is more and right side is smaller. Otherwise, what will happen? The pivot is such that in one side only one element is there and other side remaining n minus 1 element are there. Such cases may also arise. So that time we are only working on the left side. Their right side only single element will be there. So there will be nothing to do this. So the working division and all this thing will be increased. So that's why the worst case will be only working on the one side. So it will be n into n time we have to work on that. N into n, that is we have to divide it, divide with the help of pivot, then all the division, and then we are doing the sorting and then again coming. So it will be n square. Otherwise, if the pivot is balanced properly, that left side array and right side array, greater array and smaller array, if balanced, then it will be perfectly doing n log n, because it will be done as a binary operation. So it will be complete into the n log n. So here again one question is asked, like assume the algorithm considered here sort into the input sequence in ascending order. If the input is already ascending order, which following is true? So it is expected that if it is ascending order, it will take less time. We will check QuickSort. QuickSort will not work. So then it will be n square only. Then bubble sort, it will be big O notation n square, because bubble sort always it is having the two continuous loops, or you can say the iteration. So it will be n square. Then merge sort is there, big O notation n, and insertion sort, it will be having big O notation n. So you can answer this question, which one is correct. So here answer is first and last is correct. QuickSort runs with big O notation n square, and insertion sort, if it is already sorted, then it will not having the swapping time. So immediately only it will compare and it will be go or run into the big O notation n time. So one more question you can answer, that which one of the following is recurrence equation for the worst case complexity of QuickSort algorithm for sorting n is greater than or equal to 2, means if at least two numbers are there in the array. In the recurrence equation, give in the following option. C is the constant. the constant some constant timing is required to do all these things. So everywhere the constant will be there. So you have to find out this number. So answer here is Tn minus 1, T of 1 and plus Cn. Why it is? What is Cn minus 1? Total number of array minus 1. So if worst case as we discussed, that is if it is unbalanced, so on the one side it is only single number and other side it will be n minus 1. Means if we are having 6 numbers, at one side it will be, right side it will be one number and left side it will be 5 numbers. So we have to recursively do this thing, that of division and all these things. So it will take Tn minus 1 and T1 plus Cn. So it is unbalanced. The sub array on the left side of the pivot will be this having the size n minus 1, that is the worst case. And at the right side we have to do nothing, just the number has to add, so it will be having 0 timing. So this is the correct answer for this. The references. Thank you.